Welcome to Veteach. In today's session, we will be discussing about fiber materials. So, in order to define these fiber materials, first we need to observe the requirement related for choosing the material. So, they must be possible to make long, thin, flexible fibers. The second one, they must be transparent at a particular optical wavelength and to guide the light effectively. And the third requirement is that they are physically compatible materials that have slightly different refractive indexes for core and cladding. So, with all these requirements that are needed to be satisfied, the materials that are considered are glass and plastic. So, the majority of the fibers are made of glass itself. So, which consists of either silica or silicate. The variety of available glass fibers ranges from high loss glass fibers with large cores used for short transmission distances to very transparent fibers which are employed in long haul applications. Plastic fibers are widely used because of their higher attenuation than glass fibers. The main use of plastic fibers is in short distance applications and in abusive environments. Greater mechanical strength of plastic fibers offers an advantage over the glass fibers. So let us see in detail why these glass fibers and plastic fibers are being preferred, in what way their construction is being. So starting one is glass fibers. So glass is always made by fusing mixtures of metal oxides, sulfides or selenides. When glass is heated up from room temperature, it remains a hard solid up to several hundred degrees. As temperature increases, the glass gradually begins to soften until at very high temperature it becomes a viscous liquid. Melting temperature is the temperature range in which the glass becomes fluid enough to free itself quickly from the gas bubbles. So the largest category of optical fibers are being made by oxide glasses. Most common is silica, which has a refractive index as 1.458 at 850 nanometers. To have slightly different indices of refraction for core and cladding, fluorine or various oxides such as B2O3, GeO2 or P2O5 are added to the silica. So the addition of these oxides increases the refractive index, whereas doping the silica with fluorine decreases it. Remember, addition of germanium oxide, phosphorus pentoxide increases the refractive index, whereas doping the silica with fluorine decreases it. So some of the glass properties are resistance to deformation at temperatures as high as 1000 degrees. A high resistance to breakage from thermal shock because of its low thermal expansion. Good chemical durability and high transparency in both visible and infrared regions. Its high melting temperature is always a disadvantage if glass is preferred from molten state. And there is another type of glass fiber called as halide glass fibers. So fluoride glasses have extremely low transmission losses at mid-infrared wavelengths. This belongs to halide glasses in which anions are from seventh group, namely fluorine, bromine, iodine, chlorine. And the forms the core of the glass fiber. These all the elements are going to form the core of the glass elements. To make lower refractive index glass, one partially replaces ZrF4 by HAF4 to get a ZHBLAN cladding. These glasses offer intrinsic minimum loss of 0.01 to 0.001 decibels per kilometer fabricating long lengths of fiber is very difficult. And we have active glass fibers also. So these active glass fibers are incorporating rare earth elements into passive glass, which gives the resulting material to perform amplification, attenuation and phase retardation on the light passing through it. So doping can be carried out for both silica as well as halide glasses, and the two common materials are erbium and neodymium. So the ionic concentrations of rare earth elements are low to avoid clustering effects. And the one more glass fiber type is chalcedonide. So this chalcedonide glass fibers, the non-linear properties will be exploited to all the optical switches and the fiber lasers. So these glasses are used because of its high optical non-linearity and long interaction length. So the glasses contain at least one chalcogen element and others such as phosphorus, iodine, chlorine, bromine, barium, silicon and titanium. So single mode fibers have been made using AS40, S58, SE2 and AS2S3 for core and cladding. Losses in this glasses will be around 1 decibel per kilometer. So the plastic glass fibers is the last type of the fibers that we have, and these are very growing demand for delivering high speed services that has led to create high bandwidth graded index polymer optical fibers for use in customer premises. So the core of these fibers is polymethyl methacrylate or perfluorinated polymer and referred as PMMA POF and PFP POF. These exhibit greater optical signal attenuation and are tough and are durable. The core diameter of plastic fibers will be 10 to 20 times larger than silica fibers, which allow a relaxation of connector tolerances without sacrificing optical coupling efficiencies. So these are the types of glass fibers that we are going to use. Thank you.